Hello, geometry students. Welcome to lesson 6.5, properties of special parallelograms. So that's what we're talking about here. We're talking about super special parallelograms. So I want to emphasize that all of these shapes we talk about in this lesson are parallelograms. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, the diagonals bisect each other, but they each have their own special properties that go along with them. Okay? I'm going to try to make this into 2 videos only. Wish me luck. Here we go. Okay, question 1. It says parallelogram ABCD is a rhombus. What are the measures of angles 1, 2, 3, and 4? All right, so we're dealing here with a rhombus. Okay? So the definition of a rhombus is that it has all 4 sides congruent. So notice here the dashes, all 4 sides congruent. Now notice it's not a square per se because you don't have to have right angles. So angle B, angle A, angle C, and angle D don't have to be right angles. Okay. So the question is, what are these angles here at point E going to equal? And again, notice it's where the 2 diagonals intersect. Well, they look pretty perpendicular to me, right? They could be right angles, but we can't assume that. We have to know why. So let's talk about this, right? So since B and D, so point B and point D, are equidistant. We know that because they're congruent, right? Congruence, right? B and D are going to be equidistant from A and C. Equidistant from A and C. B and D lie on the perpendicular bisector of segment AC. And this is by the converse to the perpendicular bisector theorem that we learned way back in topic 5. So again, since B and D are equidistant from A and C, that means that segment BD is the perpendicular bisector of segment AC. So this means, right, that the diagonals AC and BD are perpendicular. Thus, BD is perpendicular to AC at point E. So the measure of angle 1 equals the measure of angle 2 equals the measure of angle 3 equals, not plus, equals the measure of angle 4 equals 90 degrees. And there's your angle measures. So again, one of the properties we're going to talk about in the next slide is that the diagonals of a rhombus are perpendicular. And there we go. All right, next. Another rhombus problem here. Okay, so again, it says parallel JKLM is a rhombus. How are angles 1, 2, 3, and 4 related? Okay. Well, if you look at this picture here, right, I see 2 triangles. I see a triangle here and a triangle here. So I think we can prove those 2 triangles congruent, right? So if you look here, right, we have all 4 sides of the rhombus congruent because it's a rhombus. So let's link 2 of them together. Let's link, LK with LM, and then let's link JK with JM, right? So we have a side pair here and a side pair here. Now these 2 triangles share LJ or JL, so that's congruent to itself by reflexive. So there's your 3rd side, right? So in this picture, we were given 2 pairs of congruent sides. We know that JL is congruent to itself by the reflexive property because it's shared. I said reflexive property. I pronounced the F and I wrote the F. JL is congruent to JL by the reflexive property. So therefore, these 2 triangles, and I think I named them J KL, JKL, and JML will be congruent. Triangle JML will be congruent, and that's by side, side, side. So therefore, by CPCTC, thus, corresponding parts are congruent. Angle 1 will be congruent to angle 2. And angle 3 will be congruent to angle 4. And that is by CPCTC. And there you go. Right? That's how those angle pairs are related. Okay, so let's formally introduce these two ideas. All right. So here's the first one. If a parallelogram is a rhombus, then the diagonals are perpendicular bisectors of each other. Right? Now really, it just means that they're perpendicular, but the bisector idea comes from being a parallelogram because they do already bisect. So again, the main idea is perpendicular. So in this picture here, this is a rhombus because all four sides are congruent. So yes, WY is perpendicular to XC. And you can see here in Savas, there's that picture. I'm going to go ahead and click on that, and we're going to explore, I think. Okay, so again, I'm allowed to move the vertices here. So let's move X, or let's move Z. So when I move Z, notice the four sides remain the same, and notice your diagonals, again, remain perpendicular. Okay, and again, I can scoot it left, right. There you go. Okay. All right, so remember that idea. All right, next slide. Okay, now the second property of a rhombus is that if it is a rhombus, then each diagonal bisects a pair of opposite angles, right? This is another big idea. So the diagonal bisects a pair of opposite angles. So again, in this picture here, right, we have a rhombus, right? Four-side congruent. So each diagonal bisects a pair. So angle 1 and angle 2 will be congruent, and then angle 3 and angle 4. Now we have to understand also, right, that because it is a parallelogram, the opposite angles are congruent. So angle 1 and 2, the sum of them is going to equal the sum of 3 and 4. So this big angle here, so say like this is A and that's C, those two angles are congruent. So when each of them is bisected, all of the bisected angles are going to be congruent, or the results of the bisection is congruent. So 3 and 4 will be congruent to each other, and 1 and 2. So actually, angle 1 and 2 and 3 and 4 are congruent, right? So all four of them. Same thing happens along this diagonal. So 5 and 6 are congruent because they're bisected. That corner angle. 7 and 8 are congruent. But again, if this is B and this is D, angles B and D are overall congruent by the fact that it's a parallelogram. So when that corner angle is bisected, each of the pieces or each of the smaller angles will be congruent to each other. So again, 5, 6, 7, and 8 are all congruent to each other. And again, as you look in this picture here, right, you can see that there are 4 63-degree angles and 4 27-degree angles. And again, it's because of this idea, because of the fact that the opposite angles of a parallelogram are congruent. So let's go ahead and explore this on Savas. Okay, so again, here's my rhombus. If I go ahead and drag one of the corner angles, right, notice here 68, 68, 68, 68, 22, and 22. If I bring that in, 54, 54, 54, 54, 36, 36, 36, 36. Okay, so in a rhombus, when you draw these diagonals, all four of these triangles are going to be congruent. That's a big, big, big thing to remember when we do these problems involving rhombuses, rhombi. Okay, so let's do two of those said problems right now. Okay, so example 2, ABCD is a rhombus. What is the measure of angle ADE? So AD is this angle right there, right? So let's recall, right, that we have diagonals that are perpendicular, okay, and these 4 triangles are congruent. So if I focus on triangle ADE, right, ADE, because the diagonals are perpendicular, I know that angle E here is a right angle, and because the diagonals bisect a pair of opposite angles, I know that the top angle at A and the bottom angle at A are both 53, so this angle is 53. Okay, so again, I know this because the diagonals are perpendicular. I know this because the diagonals bisect opposite angles. So now we just do our simple, if we call this x, add them up. X plus 53 plus 90 is 180. 53 and 90 is 143 equals 180, and subtract 143 on both sides. And I get a value of 37. So the measure of angle ADE is 37 degrees. And there you go. Okay, and then last but not least, right, this one. So it says, again, we have another rhombus. So what is the length of GH? So GH is a side length. We want to know what that is, right? Well, all 4 sides are the same, but only one side is labeled as 3x plus 1. So GH is actually equal to 3x plus 1, but I don't know the value of x. But I do know that these diagonals, because it's a rhombus, means it's a parallelogram, these diagonals bisect each other. So this 2x plus 3 is going to be equal to 4x minus 7. Remember that the diagonals bisect each other. And again, that's because it is a parallelogram. So I can set 2x plus 3 equal to 4x minus 7. I'm going to combine my x terms by subtracting 2x. 3 equals 4x minus 2x is 2x. The minus 7 comes down. I'm going to add 7 to both sides. 10 equals 2x, and then divide by 2. And I get an x value of 5. So again, because it has 4 congruent sides, I know that GH is also equal to 3x plus 1. Let's plug in 5 in for x. So GH equals, 3 times 5 plus 1. 3 times 5 is 15, plus 1 is 16. GH is 16. Okay, that's video 1. Good, we made it. So we'll only make a second video coming up here on rectangles and squares. All right, great job. Look forward to the next video.